So, hello guys. So let me add these two concepts. This is 1 over x. This more like 1 over x, but this one is having square. The meaning of this line is absolute value. So, does this limit exist? In the previous video, we said 1 over x does not exist if x tends to 0. Because limit from the left will not be equal to the limit from the right, and you know what we said about it. If you have not watched the previous video, probably you should go and watch and check what to explain on 1 over x. But if it is 1 over absolute value of x, this is not my focus for today. This one will exist. Why? Because the limit from the left, if tending to negative infinity, now you know it's going to give you 1 over what? You don't even need the limit from the left. Not just this directly. It's not tending to negative infinity. Now, the x from the left will be tending to 0.1 minus 0.01 minus 0.00 continuously like that, just getting close to 0. But since it is absolute value, absolute value, absolute value, what absolute value does is that it takes away the minus. That is the meaning of like the absolute value without sign. So 1 over this will still tends to what? Positive infinity, even though it's coming from the left. Because for us to get the negative, this absolute value has taken charge of it. So whether from the left or from the right, the whole answer will still be what? Positive infinity. So this one, it exists because of the absolute value. Watch the previous video, part 1. When you get this, you will know what I'm talking about here. So instead of minus infinity, now we get positive infinity. So this, because this absolute value. So this one does not exist, but this one exists. From the left of this equal to from the right. From the left of this not equal to from the right. Though that's not my business for today. I just want to make it clear. Now, if this one tends to 0 also, 1 over x squared, does this exist or not? It does. Because from the left, if it is 0.01 is minus 0.001 or minus 0. Whatever. Once it's getting close to 0, Now, this our value of x is getting close to 0. See, as x tends to 0. So as you keep on inputting this value, as s is getting close to 0, as you keep on inputting this value for x, then the function will be getting close to infinity. If you input this value for x, what will you get? You'll be getting like 100 or 1000, because this is square. For this particular one, if you input this for x, you'll be getting like 10. Why are you getting 10 and not minus 10? Because it's absolute value. So you are using 0.1 instead of minus 0.1. For this one now, this 0.1 square is 0.01. Are we together? Even this minus 0.1 square is still 0.01, because this is even function. So whenever the power is even number, then the negative will be dealt with. Now, minus times minus is plus. So 1 over square of this will still give you positive answer. 1 over square of this, s square, will give you positive answer. 1 over square of this will give you positive answer. As you continue, as the x is getting close to 0, your answer will be tending towards infinity, whether from the left or from the right. From the right, x will be tending to 0, 0.1, 0.01, 0.0001, continuous like that. This is from the left, this is from the right. So whether it's from the left or from the right, you still get the same answer, positive infinity. Because from the left, we're not giving negative. Why? Because this square will take it away. So that's that for that. This guy exists, this guy exists, this guy does not exist. So now our business for today now. Let's start from the basic. Now limit as x tends to 0 of x raised to power 7 minus 2. So since x tends to 0, direct substitution. Using direct sub, x raised to power 7, that's 0 raised to power 7 minus what? 2. Using direct sub, as x tends to 0, So it's going to give us what? 0 minus 2. So it's equal to what? Minus 2. That's the answer for that. Now, number 2, we have about 35 questions here. Number 2, limit as x tends to 3. So you have to be patient and get everything. Of 5 minus 2x minus s squared, using direct sub, like you substitute x directly. Like there's no complex method. It's just a direct substitution. So here we have what? 5 minus 2 multiplied by 3 as x tends to 3. So it's going to give us what? 5 minus 2 multiplied by 3 minus what? 3 square equals to what? 5 minus 6 minus 9 equals to what? Minus 1 minus 9 equals to what? Minus 10. Are we together? Yes. I'm coming. This is minus s square. You are subtracting s square. It is not our x that is negative. If it's our x that is negative, you get plus 9. You are subtracting s square minus s square, so it's minus 9. Don't make that mistake. If x is minus 3 square will give us what? Plus 9. But our x is not the one carrying the minus. Are we together? The minus is in the function you are subtracting. So our x is 3. 3 square is 9. So the answer is minus 10. So the next one, we have limit as x tends to 0 of what? X minus. So if you try direct substitution, this is it. Using direct sub, because I don't have space. I'm not try direct substitution in everything, but always make sure you try direct substitution first because you may get an answer. If I try direct substitution as x tends to 0, what will happen? So this one will be 0 minus 0 square, which is same thing as 0, minus 0 raised power 4, which is same thing as 0, over what? 3 times 0. So everything will give me what? Is 0 over 0. So 0 over 0 is what? Indeterminate. The answer is not 0. 0 is different from this. So this guy is what? Indeterminate. Indeterminate. Are we together? You can't determine it because there's 0 over 0 is indeterminate. So you have to look for a way to eradicate that. So what are we going to do now? Now, these are what we are going to do. We are going to factorize x from the numerator. So, whenever you get indeterminate, there are methods you can use to deal with them. We have different methods. Number one, we have by factorization. I've explained this basic in the previous video. We have by rationalization. If the question is in short form, rationalization. How by using standard limit, standard limit value. We have using L'Hopital's rule. I think there is one more. The previous video I've explained this. So when do you need to use this? Once your direct substitution give you indeterminate value. As a substitute x direct, here we substitute x direct, we get a value. So you don't need to try any other method. Here substituting x direct, you get indeterminate. So you have to use another method that is suitable for that question to remove this indeterminate. So which method is suitable here? Factorization. So what are we factoring out? We want to factor out x. Now it's going to give you what? Limit. Please, as you are doing your factorization, you are writing the question and you are adding the limit. It's going to give us limit as x tends to 0 of x into 1 minus x minus s cubed over what? 3x. See, x times 1, x times x, this s square, s times this. So are we together? So what happened? X here, cancel x here. So what do you have left? It becomes limit. See, if you don't always add your limits, it's because of direct substitution here that I don't need to add limit because I just substitute x direct. If you don't add your limit, as you keep on getting new value, you are solving another question like that new. So you have to be adding limit as x, what your limit is tending to. Limit as x tends to 0 of 1 minus x minus s cubed over 3. 1 minus x minus what? S cubed over what? Over 3. Now, as your x tends to 0, what do you have? It becomes 1 minus 0 minus, what's s cubed? Is 0 cube, abi? 0 over what? 3. Is equal to what? 1 over what? 3. Is that clear? So, 1 minus 0 over, sorry, this over is everything. Oh, so the answer is 1 over 3. So I use factorization to take away determinant. Don't ever leave your answer like this. This is not an answer. So you have to determine an answer using another method. Now for this guy, if I use direct substitution direct, what will I get? Using direct substitution, you have to be writing it, but because of space, you will write using direct substitution. Is that clear? So if you use direct substitution, as x tends to 5, this one will give you 5 square minus 25 over, as you know, x is tending to 5, 5 minus 5. 5 square is 25, 25 minus 25 is 0, 5 minus 5 is 0. That's what indeterminate. It gives you 0 over 0. So you write 0 over 0, then you write indeterminate. So which method can we use to take away the indeterminate? Factorization method. So by factorization, using factorization, what do we have? X squared minus 25 is same thing as what? X minus 5, x plus 5. Don't forget, you are going to write then equals to limit as x tends to 5 of x minus 5 over x plus 5 over what? S minus 5. Always add this to each step when you are breaking it, the concept down. This equals to this, s times s squared, s times 5 plus 5x, this minus 5x, it cancels, minus 5 times 5 minus 25 over this. So now this cancel this. So now what do you have? Is equal to limit as x tends to 5 of what? X plus what? 5. So as your x tends to 5, what do you have now? 5 plus 5, which is what? 10. So that's that for that. Now for the next one, limit as x tends to 4 of 2x plus 8. Now if you substitute 4 direct, this one is going to give us 2x, 8 plus 8. This one will give us what? 16 minus 16. That's 16 over 0. That one is not indeterminate, but it is undefined. So we need to look for another way to solve it so that we will not get undefined. Except indeterminate, 0 over 0. Always also make sure that your denominator should not be 0, even though you have a value at the numerator. Here both numerator and denominator are 0. That's why it's indeterminate. But if the denominator alone is 0, it's not indeterminate, but it's undefined. So yet still make sure that you don't have 0 at the denominator. It's very important. So how do we see? This one give us 2 times 4. 8 plus 8, 16. 4 square, 16 minus 16, 0. That's 16 over 0. So how do we eradicate that? How do we make sure that we don't get 0 at the denominator? So here, we're also going to use factorization. So by factorization, always use direct sub. I've tried my direct sub, but because of space, direct sub is 2 times 4, substitute x direct. It's going to give us 16 over 0. Now, using factorization, we are going to get what? Now, factorize out 2 from here. You are going to have 2. So it's going to give us limit as x tends to 4 of what? 2 into what? X plus what? 4. Factorize this one too. X minus 4, x plus 4. This one is same thing as x squared minus 16. Now, if this guy cancel, here, you have 2 over x minus 4, right? And 2 over x minus 4, if you put 4, you still get 2 over 0. Is that clear? So, even there are sometimes you use one of the method, you still get undefined or indeterminate. This is it. This guy is same thing as this. 2 times x, 2x, 2 times 4, 8. This one is same thing as s times s, s squared. S times 4, 4x. This one times this minus 4, it cancel. Minus 4 times 4, minus 16. So I broke it down with factorization so that I can cancel out and have only this. So if I still have only this and I later put my 4, I still have 4 minus 4 is 0. So that means factorization cannot still solve it. Now what can we use? Let's use the L'Hopital's rule. Yeah, we cannot rationalize because it's not solved. And there is no need of standard limit here. There is nothing that I want to put standard. So let's use L'Hopital's rule. Now, I've not discussed L'Hopital's rule before, but the meaning of L'Hopital's rule state that using of L'Hopital's rule, please learn that rule and always avoid to think about it first. try every other method, because you have to master every other method without this guy. Because most of the questions they will tell you without using L'Hopital rule. They will tell you not to use L'Hopital rule because this is a very shortcut. Like, this is just the best shortcut you can ever pass to solve limit. It's too short. Are we together? For some particular question, no short though. So here you have L'Hopital rule say that limit as x tends to a of f of x over g of x equals to limit as x tends to a. Sorry. It say limit as x tends to a particular value of f of x over g of x. You only use L'Hopital rule whenever you have fraction. If it's not fraction, the L'Hopital rule is not talking about that. And you know this question is fraction, so you can use L'Hopital rule. As x tends to a of f prime of x over what? G prime of what? X. The meaning of f prime is differentiation of f of x. The meaning of g prime is differentiation of g of x. Note, this is not quotient rule. Quotient rule, you know you have formula v du over ds minus v dv over ds over v square for calculus. But this one, L'Hopital is saying that you differentiate the numerator separately. Differentiate the denominator separately. So it's going now. We are going to have what? Limit as x tends to 4, right? Of now, if you differentiate the numerator separately, differentiate 2x plus 8. That's 2 plus 0. No, 2x give you 2. If you don't know how to differentiate, drop it in the comment section so that we know how to tackle that. But you are not teaching calculus now. You know how to differentiate now. If you have let's not waste our time. If you differentiate 2x, you get 2. If you differentiate 8, you get 0 over. Now, if you differentiate x squared, you get 2x, right? If you differentiate minus 16, you get 0. So this one, 2 minus 2 plus 0, 2x minus what? 0. Now you can put your x4 direct as x tends to 4. So this guy give us what? Now 2 over what? 2 times what? 4. That's what? 2 over 8 equals to 2 over 8 equals to what? 1 over 4. L'Hopital rule is very wonderful, but always try to avoid it because you must master every other method, because most of the case they will ask you not to use it. So our answer is 1 over 4. Now, the next one, limit as x tends to 3 of x minus 3 over 27 minus s cubed. Now, if you use direct substitution, the 3 minus 3, you know s is going to 3, so put 3. 3 minus 3 is 0. This one, 3 cube is 27. 27 minus 27 is 0. You have 0 over 0. So direct substitution doesn't work. So let's try if, what's it called now? So what are we going to use now? Don't think of L'Hopital rule first, even though it's a fraction. Now, let's do factorization. Factorization should work. So it's going to give us what? Limit as x tends to 3 of what? X minus 3 over. Now, do we remember cubic factor? Cubic factor that if you have a cube minus b cube equals to a minus b over what? A square plus ab plus b square. I hope you remember this formula. Cubic factor. This equals to this. So that's all we want to do here. So and this 27, don't forget, is 3 cube. So if you have 3 cube minus s cube, so if you have 3 cube minus what? S cube, which is 27 minus s cube. So it's going to give us what? I don't know, this our a, this our b. So we are going to have 3 minus what? X into what? 3 square plus 3x plus what? S square. Are we together? So this is the breakdown of this. So this guy is going to give us what? 27 minus s cube. We are going to have what? 3 minus x into what? 3 square, right? Plus 3x plus what? S square. Are we together? Yet this guy cannot cancel out this guy. It can't cancel out. So what are we going to do? You can multiply the numerator and the denominator by minus 1. Whatever you want to do to the numerator, once you do it again to the denominator, then you have not changed anything. Are we together? So Let's multiply the numerator and the denominator by minus 1. If you multiply the numerator by minus 1, so we get limit as x tends to 3 of what? Minus x plus 3 for the numerator. If you multiply this by minus 1, minus times x, no, by minus 1, minus times x minus x, minus times minus 3 plus 3. Multiply the denominator by minus 1. Don't open the bracket, just put the minus there. 3 minus x, are we together? Over what? 3 square plus 3x plus s square. So, 3 minus x is same thing as, this plus 3, this minus x, this also minus x, this plus 3. This same thing as 3 minus x. So, this one cancel this. So, what do we have left? Is equal to limit as x tends to 3 of 1 over, are we together? Minus 3 square. What's 3 square? 9 plus 3x plus s square. So now you can put your 3 direct. As x tends to 3, what do we now have? This minus, you can bring it out. We have minus what? As x tends to 3, sorry. We now have minus what? 1 over 9 plus 3 times x, that's 3 times 3, plus s square, that's 3 square, which is still 9. Are we together? Now our x tends to 3. So at the end of the day, we have 9 plus 9 plus 9. We have 1 over 27 with this minus. So the final answer is minus 1 over what? 27. Very wonderful. So this is also factorization using cubic factor. So here we have what? Limit as x tends to minus 1 of this over this. Now let's do direct substitution. Minus 1 square is plus 1. Abi? Plus 1 minus 1 is 0. Minus 1 square plus 1, right? If you have minus 1 here, minus 6 times minus 1, you get plus 6, right? Plus 6 plus 1 plus 7. 7 minus 7 is 0, so we get 0 over 0. You can try that direct substitution in your note, you get 0 over 0. Just put minus 1 direct. Minus 1 square is 1. 1 minus 1 is 0. Minus 1 square is 1. 6 times minus 1 is minus 6. Times this minus is plus 6. 1 plus 6, 7 minus 7 is 0. So indeterminate. So what are we going to do? Let's do factorization. So if you do factorization, we get limit as x tends to minus 1. Are we together? Limit as x tends to minus 1 of what is this is going to give us x minus 1, right? S plus 1. If you multiply this, you get s square minus 1. So this guy is same thing as what? X. I'm coming. Let me check. So here we have x minus 7, x plus 1. Yeah. See, x times x, s square. X times 1, x minus 7 times x minus 7x. So minus 7x plus x minus 6x minus 7 times 1 minus 7. Expand it, you will get this. So this guy, cancel this guy. So here we now have x minus 1 over. So it has now changed to limit as x tends to minus 1 of what? X minus 1 over what? X minus 7. Now put your minus 1. As x tends to minus 1, you now have the numerator become minus 1 minus 1. Or the denominator become minus 1 minus 7. So here you now have what? Minus 2 over what? Minus 8. Minus cancel minus. 2 over 8 is what? 1 over 4. That's the answer. Now the next one, number 8. Limit as x tends to 0 of this. So for this one, if you use direct substitution, if you put 0 direct, 0 raised by minus 1 is 0. 3 times 0 is 0, you get 0 here. 2, since it's 0, since x is 0, this one will give 0, 0. So you have indeterminate. Everything will be 0 over 0. You can write it in your note and see how. Using direct substitution, always first of all try direct substitution. You can't write it out because of space. So direct substitution gives 0 over 0. So now, what are we going to do? Before we know what to do, let's interpret the question very well. X raised to power minus 1 is same thing as 1 over x. So here we have the question becomes limit as x tends to 0 of 1 over x plus 3x over, this one is same thing as what? 2 over x, because this is inverse, the x comes down, plus x. So what do we have? So it becomes limit as x tends to 0 of, you have to add this. Okay, let me just write it here. I'm trying to manage space. So it's going to give us limit as x tends to 0 of, find the LCM of the numerator. What's the LCM? X in x1, 1 times 1, 1, plus this over 1, 1 in s times 3x, 3x square, over, for the denominator, what's the LCM? X in x1, 1 times 2, 2, plus 1 over this over 1, 1 in s times x, s square. So this guy is showing to limit as x tends to 0 of what? 1 plus 3, 1 plus 3 s square over x divided by 2 plus s square over x. So it's going to give you limit as x tends to 0 of what? 1 plus 3 s square over x. This one will change to multiply by, and this one will go up. X over what? 2 plus what? S square. So what happened? This cancel this. So it's going to change to limit. Always be writing this until the last substitution. Limit until the final part where you will now be putting your x rather. Now it's going to change to limit as x tends to 0 of what? 1 plus 3s square over what? Over 2 plus s square. 2 plus what? S square. Now, as your x now tends to 0, you now write as x tends to 0, it's now be 1 plus 3 times 0 square over 2 plus 0 square. So this one becomes 0, this one becomes 0. Your answer now turns to what? 1 over what? 1 over 2. This is the final answer. 1 over 2. 1 over 2. That should be clear enough. Or you can just back it a little and play that part again. That should be clear enough. So here we have limit as x tends to 1 of 1 over x minus 1 minus what? X plus 2 over x plus 3. If you put direct substitution, in fact, this one is already at the numerator alone. Numerator is also fraction. You already have 0 here. Are we together? So try to eliminate that. So you have undefined at the top, which has make the whole concept to be invalid. Now, what do we have to do? Let's find the LCM first. No, yeah, I did not do any factorization. I just like, how can I put it? Express it in another, like to give me a more proper fraction. Are we together? By finding the LCM. So yeah, to me now, I can still even say for this one now, I can still even say I use direct sub. Though it's not direct sub because I still pass through some step. Or should I even call it LCM method? Are we together? But I don't think. But you get what I'm trying to say now. This one now, let's find the LCM too. Because if you use direct sub direct, it's not going to work. So what's the LCM of the? So it's going to give us limit as x tends to. This video will be long because I still have about 20 something questions left. So please just do as much as possible to watch everything. 1 over x minus 1. So what's the LCM of the numerator? X minus 1. X minus 1 and x minus 1, 1. 1 times 1, 1. Minus this over 1. 1 in s minus 1, s minus 1. S minus 1 times this, you get what? X minus 1, s plus what? Plus 2. Is that clear? Over what? S plus 3. Are we together? So now this guy is going to give us what? Now can you see now that? Yeah. So what do we get here? We get what? It's going to give us limit as x tends to minus. This one cannot cancel this because this also have impact in the numerator. We have 1 minus what? X minus 1, x plus 2 divided by what? X minus 1, x plus 3. I hope you understand this. Why? Because it's going to give us divided by x minus 1, then divided by x plus 3 over 1, which is sent it to multiply by 1 over x plus 3. So at the end of the day, this guy will be at the numerator. Just do it the easy way. We get this. Like this over, if I say 1 over 2 over 3, it's same thing as 1 over 2 times 3. So that's what happened because it's 1 over 2 divided by 3 over 1. It's same thing as 1 over 2 times 1 over 3. So 1, 2 times 3. So are we together? So what are we going to do here now? What are we going to do? So since it's still same, we still get 0 here because if you put 1 minus 1 is 0 times this is 0. So there are other ways. Yes, this can be solved. I don't want to use L'Hopital's rule, but because of my time, I think I'll be tempted. L'Hopital's rule is actually a temptation. Please know that because it's a shortcut. I think I'll be tempted to use L'Hopital's rule. Yes, but let's just see what's happening. So let's just use L'Hopital's, but that's actually a temptation. So if we expand, it's going to give us limit as x tends to 1 of 1 minus x times x square, x times 2 2x, minus 1 times x minus x plus 2x, that's plus x, minus 1 times 2 minus 2 over what? S times x square, s times 3 3x, minus 1 times x minus s plus 3x plus 2x, minus 1 times 3 minus 3. The way I'm seeing it now, there's something I can do, but I can't even see that something. So that's why I want to use L'Hopital. So you are going to write using L'Hopital's rule. I know the rule. You are going to differentiate the numerator, differentiate the denominator, then put your x. It's not quotient rule. Quotient rule, you'll be doing VU, VDU, whatever. This one now. Now, differentiate the numerator is going to give us, please, you are going to write using L'Hopital's rule. If possible, write the expression of the rule, but no space. Using L'Hopital's rule, which state that limit as x tends to whatever of f of s over g of s is equal to limit as x tends to that whatever of f prime of x over g prime of x. Prime is differentiation. So if you differentiate 1, we get 0. Minus, if you differentiate x squared, we get what? 2x. If you differentiate x, we get what? 1. If you differentiate minus 2, we get 0. If you differentiate x squared, we get 2x. If you differentiate 2x, we get plus 2. If you differentiate minus 3, we get 0. So now you can put your 1 direct. Now as x tends to 1, now minus 2x, that's minus 2 times 1, abi, which is minus 2 plus 1, that's minus 1 over 2 times 1, 2 plus 2, 4. The answer is what? Minus. The answer is what? Minus what? 1 over 4. Is that clear? For those of us who doesn't understand differentiation, don't worry, just drop it in the comment section. 1 is 0. This minus. Sorry, I've made a mistake. Sorry. This minus is outside. It has to multiply everything in the bracket. Are we together? So if you differentiate this, you get 2x. Differentiate this, you get 1. Differentiate this, you get 0. So now this guy will now change to minus 2x minus 1. It's not 2x that have the minus, it's everything. So at the end of the day, we are going to get limit as x tends to 1 of what? Minus 2x. Minus times 2x minus 2x minus times 1. That's minus 1. Minus 1 over what? 2x plus 2. So as your x tends to 1, you now get what? Minus 2 times 1 minus 1 over what? 2 1 plus 2. So which is what? Minus 3 over what? Over 4. Got minus 2 minus 1 is minus 3. So that's that for that. Now the next one, we have limit as x tends to infinity. So direct substitution. Using direct substitution, we are going to have x raised to power 4, right? X raised to power 4, so it's going to give us what? Infinity raised to power 4 minus what? 2 multiplied by what? Infinity cube, right? Plus infinity minus 1. So what are we going to get? Infinity raised to power 4 is what? Infinity. Watch the properties of infinity in the previous video. I've described properties of infinity. Infinity cube is infinity times 2 is still infinity. Plus what? Infinity minus 1. If it is about this addition, it would have been better, but there is a subtraction. Infinity minus infinity is indeterminate. So this answer is indeterminate. You can't subtract this to infinity. Why? Because you can't say it's 0. Because the one that produced this is power of 4, the one that produced this is power of cube. You don't know which one is bigger, so you can't subtract them. It's indeterminate. So since this is indeterminate, then whatever you have here, everything is indeterminate. So what are we going to do now? You do factorization. Is that clear? Now let's factorization. Direct substitution give us indeterminate. How do we factorize? You can bring out x4. Yes, you can bring out x4. So it's equal to what? Limit as x tends to infinity of what? X4. Then what do you now have in the bracket? This one become 1, abi? What do you have here? Minus 2 over x. This times this will give you minus 2x cube. I hope we know. Multiply it. Just put it down, multiply it. This one will give us what? 1 over s cube. Am I right? This times this will give you x minus 1 over x4. S4 times this will give you minus 1. Is that clear? So we are done. That's very good. So now what are we going to do? Now we can now substitute our infinity direct. So this one will give us what? Infinity. So as x tends to infinity, so now we are going to get infinity raised to power 4 into what? 1 minus 2 over infinity plus 1 over infinity cube minus 1 over infinity raised to power 4. Is that clear? So here is going to give us what? What's infinity raised to power 4? Infinity. 1 minus 2 over infinity is 0. Go and watch the properties of infinity in the first video. 1 over infinity cube is 0. 1 over infinity 4 is 0. So it's going to give us what? Infinity multiplied by what? 1. Is that clear? So our answer is what? Infinity. Wonderful. It's not hard. Everything here is same thing as everything here. Because if you don't do it like this, we get, do you get? This times this times this. That's just as simple as that. Now for this one too, if you do direct, this is tending to negative infinity. Let's do direct substitution. Now this one we are going to get direct sub is going to give us what? 6 into what? Negative infinity cube, abi? That's 6x cube plus what? Negative infinity square, right? Minus what? 2 times what? Negative infinity, right? Plus what? Plus 4. So negative infinity cube times 6, we are going to get negative infinity. Negative infinity square, we are going to get positive infinity. Minus 2 times negative infinity, what are we going to get? Positive infinity plus 4. This times this. Infinity raised to power anything. Are we together? Except 0. That one is indeterminate. Whether infinity raised to power 1 or 2. Infinity raised to power any positive number is still infinity. So that's why we are getting infinity. Infinity times any number. If it is positive number except 0, you get infinity. If it is negative number, you get negative infinity. This one is minus and minus. So it's changed to plus. This one turns to infinity. So because we have minus infinity plus infinity, it's still same thing as infinity minus infinity. And I told you whenever I say infinity minus infinity, it's indeterminate. So this guy gone. So now let's use direct sub. Let's factorize. So it's going to change to what? Limit as what? X tends to what? Negative infinity of. Now what are we going to do? We can bring out s cube. Yeah, bring out the highest power, s cube. That's when it's going to make sense. This one will remain 6, right? No, it's 6s cube plus what? Plus 1 over x. S cube times 1 over x, it will give you s square. This is it. S cube times 1 over x. X here 1, x here square. So what do we have left here? Minus 2 over s square. Minus 2 over s square times s cube, you get minus 2x. What do you have left? Plus, that's 4, abi? So you are going to get 4 over what? S cube. S cube times 4 over s cube. This cancels, it remains 4. So everything here, same thing as everything here. So now as your x tends to negative infinity, so here you are going to have what? Negative. So it's going to give you what? Negative infinity cube into what? 6 plus 1 over what? Negative infinity minus 2 over what? Negative infinity square plus 4 over negative infinity what? Cube. Is that clear? So this one is going to give, what's negative infinity cube? It's still negative infinity into what? 6 plus 1 over negative infinity. What's the answer? Minus 0, abi? Yes, you can write. You can bring up this minus, and this plus and minus will change to minus here. So you can bring out the minus, this minus. 1 over minus 2 is same thing as minus 1 over 2. So you can bring out this minus out. So 1 over infinity will give 0. So there you have minus 0. Are we together? minus, you can bring out this minus 2. Then 2 over infinity square, you get, you can bring up this minus, you still get 0 there, plus 4 over infinity cube is 0. You get what I'm saying? Because some people, they will make me just bring out this minus 1 over 2 is same, 1 over minus 2 is same thing as minus 1 over 2. So 1 over minus infinity is same thing as minus 1 over infinity. And 1 over infinity is 0. You get minus 0. This minus, yeah. So here you have 2 over minus infinity square. 2 over infinity square is 0. This minus is this. 4 over infinity cube is 0. So whether there is minus or not, so it's going to give us negative infinity into what? 6. 6 minus 0 minus minus 0 plus 0, everything is still 0, rubbish. So minus infinity times 6 is what? Minus infinity. That's the answer. So the next one, as x tends to infinity. Now, if you have fraction, when there's another pattern we use. If you do direct substitution here, 7 times infinity 4 is infinity. This one will still give us infinity. So this one minus is already indeterminate. That you are subtracting infinity and infinity is already indeterminate. So assuming everything up is even addition and everything there is addition, you get infinity over infinity, which is what? Indeterminate. So the subtraction has dealt as proving that it's indeterminate. Even the infinity over infinity will still give, because if you put infinity direct, everything here will be infinity. Assuming we don't have negative, everything here will also be infinity. Infinity over infinity is indeterminate. And further, you even have negative at the top, it's indeterminate, because you can't subtract infinity from infinity. You don't know which one is bigger. They are not the same thing, even though they bear the same name. So you can't determine it. So now, the method we are going to use is that. Now, we watched the last, the part 1 and the previous video, the basic. Then you won't have problem with this. Is that clear? So now, you are going to divide everything in the question by the x with the highest degree at the denominator. And I told you why it must be at the denominator. See, don't just use it, know the reason. Watch the previous video on it. Leave me that part 1 and go and watch it. You understand? So whether the numerator have the highest, yet you are picking from the denominator. So in the denominator, which x have the highest power? This one, s cube, right? So you are dividing everything by s cube. I'm going to give you limit as x tends to what? Infinity of what? 7x raised to the power 4 over s cube plus 8x raised to the power 3 over s cube minus s square over s cube, everything over 2s cube over s cube plus 4x over s cube plus 1 over what? S cube. So here, s cube cancel s cube. So it's going to give us limit as x tends to infinity of this one, s cube here, it will remain 7x there, right? 7x plus s cube cancel s cube, we have plus 8 minus s square here 1, here we have minus 1 over x, right, over this one, s cube cancel s cube, we have 2 plus 4 over x cancel to 1 here, so it remains s squared there, right, plus what? 1 over what? S cube. Now you can now put your x as infinity. As x tends to infinity, what do you have? You have 7 multiplied by infinity, 7x plus 8 minus 1 over infinity over 2 plus 4 over infinity square plus 1 over what? Infinity cube, which is what? Is equal to 7 times infinity, infinity, plus 8. 1 over infinity is 0. You don't know how it's 0. Go and watch the first video. This one is what? 2. Because 1 over a very big number, the answer will be getting very small to 0. So that's it. That's the properties of infinity. Plus 4 over infinity square is 0. Plus 1 over infinity cube is 0. This plus, sorry. So at the end of the day, what do you have? Infinity plus 8 is still infinity. Minus 0 is infinity. Over what? 2 plus 0 plus 0, that's 2. Infinity over 2 is infinity. Are we together? So our answer is what? Is infinity. Whenever you have fraction like this and your x is leading to infinity, am I communicating? then you are going to do something like this. Are we together? Always avoid L'Hopital's rule. Run from L'Hopital's rule. It can finish you. I know what I'm saying. It can finish someone. So learn every other method very well. It is when Ekpa Boromo, when they are like there is nothing you can do again, then you can use L'Hopital's rule. Except if it's stated in the question that use L'Hopital's rule, because there are some questions that are very advanced. That in fact using L'Hopital's rule is going to give you crazy vibe because you are going to differentiate as if you are going to heaven. So, but there are some direct questions. Always avoid L'Hopital. Though not that you won't get the right answer, but learn some standard because many cases they will tell you not to use L'Hopital's rule. And if you have mastered L'Hopital, you have not mastered the other. You will just be looking. So limit access tends to infinity of this. So here you apply the same method. Are we together? Solve this one. Then drop your answer in the comment section. Solve this. This one, this is it. Yeah, screenshot it like that. Access tends to infinity of 3x plus 4x5 minus x plus 1 over this. This is I will call it number 8, number 9, 10, 11, 12. Number 12, solve, drop it in the comment section. Solve number 12, drop it in the comment section. I repeat, if you are serious, do that and drop it in the comment section. So now number 13 now. So number 13, we have limit as x tends to negative infinity. Are we together? So of this, now let's expand the numerator. The denominator is going to give us what? X tends to what? Negative. Limit as x tends to negative infinity of what? 6x squared minus 4x. You don't understand number 11 and ask you to solve 12. Listen now because I'll be expecting your answer of that number 12 in the comment section. S times x, x squared. S times 2, 2x. Minus 1 times x minus x plus 2x plus x. Minus 1 times 2, that's minus 2. So this is the question. So you are going to divide everything. If you put minus infinity direct, you get indeterminate. Try it. Yeah, substitute. Use direct substitution, you get indeterminate. So now you are going to divide everything in the question by the leading coefficient of x. So it's going to give us what? Limit as x tends to what? Negative infinity of what? 6x squared over s squared minus 4x over s squared. Leading coefficient of x in the denominator, but since they are the same thing, then you don't have problem again. Plus 2 over what? S squared over what? S squared over s squared. The denominator become x over s squared minus what? 2 over what? S squared. Exactly. This cancel this. This cancel this. So it's going to give you limit as what? X tends to negative infinity of what? 6 minus 4x over s squared, that's 4 over x, right? Plus 2 over s squared over, this has cancelled. So s squared over s squared, that's 1. Plus what? X over x, s squared over s squared, that's 1. X over s squared, we have 1 over x. Because this x will cancel. Minus what? 2 over what? S squared. So as what? As x tends to negative infinity, you are going to get what? 6 minus 4 over what? Infinity plus 2 over what? Infinity square. Everything over 1 plus 1 over infinity minus what? 2 over what? Infinity square. So you are going to get 6. 4 over infinity is 0. 4 over infinity is 0. 2 over infinity square is also 0. So at the numerator, you have 6 alone. 1 over infinity is 0. Minus 2 over infinity square is also 0. So you have 1 plus 0 minus 0. So you have 1. 6 over 1 is equal to 6. The answer is 6. Are we together? So this one, instead of rationalization, you can rationalize here. But since it's tending to infinity, you don't have to waste your time on rationalization. You can use this method. Even though there is root, this is the way to do it. Are we together? Now listen. Here you are going to have, it's going to give you limit. If you do direct substitution to be indeterminate, try it too. So now using that other method, x give us negative infinity. So over what? Divide everything in the question, everything by the leading exponent of x, by the x that is leading, that have the highest degree at the denominator. At the denominator. So this one give you root what? 64 s square minus 5 over, now this is where the issue is. The x that is leading at the denominator is x raised to power 1. Now listen, you understand now. 3x over x, I'm coming, just listen, plus 2 over x. Why did I use x square now? Because this one I have root. There is a root 6x4 minus 5. Now if I have 1x, if I want to take it inside it's not this x square that I use to divide. If it's this x square, then you have x square. I'm using this x, it's always from the denominator. This guy has root. If I want to bring x from the denominator to come and do a particular job inside root, it will become square, right? Because root x square is x. So if I'm bringing this x, if there is a root, if I'm bringing this x inside, it will change to square to show us that it is x. If I put just x, that means it's not x that I brought in. Maybe I brought in what was it called now? Maybe is it what did I even bring in now? No, root x, and that means I bring in x raised to power half. Do you get? So if I'm bringing in x inside the root, if it is x square, if you want to enter it, it becomes x4. Do you get? So it's become, the x is coming inside the root, so it will carry square to maintain that x gene. Because square will cancel root to remain x alone. So it's still x that is there. It's because of the root. Please take note of that. So this one is going to give you what? Limit as x tends to infinity of what? Now x square cancel x square, right? Of root. What do you have now? 64 minus what? 5 over x square over x cancel x over 3, right? Minus what? 2 over what? X. Do we get? So it's going to give us, now as your x tends to infinity, you are going to have what? Root 64 minus 0, because 5 over infinity square is 0, divided by 3 minus 2 over infinity. 3 minus 2 over infinity. So it's going to give us what? Root 64 over 3 minus 2 over infinity is 0. So we are going to get what? Root what? 64 over what? Over 3. So which is what? 8 over what? 8 over 3. That's the answer. Is that clear? So you know really go far. You know go far. So now cheap. No go far at all. Now, next one, we are still going to number 35, and this video is close to an hour already. I hope you'll be able to watch everything because it's going to be best for you. So this one is what? Limit as what? X tends to negative infinity of what? X minus 4x cubed. Now what are we going to do? Divide everything. If you do direct sub, we are going to get indeterminate, infinity over infinity, all into raised power 4. So that infinity over infinity alone is already indeterminate. Even the numerator, infinity minus infinity, is indeterminate. So here we have divided everything in the question by the leading part, by the x that have the highest degree at the denominator, which is s square, right? So divide everything by s square. X over what? S square minus what? 4s cubed over what? S square over 5 over s square plus what? 7s square. 7s square over what? S square. Oh, sorry, the leading power is x raised to power 5. Oh my god, it's s raised to power 5. So this one become s raised to power 5, s raised to power 5, s raised to power 5, s raised to power 5 plus what? S raised to power 5 over s raised to power 5. Everything. Sorry. Oh my god. Bracket raised to power 4. So this guy is going to give us limit as x tends to infinity, negative infinity of what? This one becomes s cancel 1 over x4, right? Minus what? Cube cancel, so you have what? 4 over what? S square, isn't it? Over what? 5 into what? S raised to power 5, right? Plus 7 s squared cancel 2 from the denominator, it remains s cubed plus s5 over s5, you have 1. Everything raised by what? 4. So now as your x tends to negative infinity, what do you have here? So you are going to get 1 over negative infinity, bring the negative here, then put the infinity here. Infinity raised to power 4. Okay, you can put it here, don't worry. Negative infinity raised to power 4, 1 over x4 minus 4 over negative infinity square, over 4 over negative infinity square over 5 over negative infinity raised to power 5 plus 7 over negative infinity cube plus 1. Everything to the power of 4. So what do you get? The minus infinity raised to power 4, that's infinity. 1 over infinity is 0 minus infinity squared, that's infinity. 4 over infinity is 0. Don't forget you have power of 4 outside. So minus infinity raised to power 5 is going to give you minus infinity. So 5 over minus infinity, you get minus 0. Minus will come out. So 5 over infinity is 0. Minus infinity cube is minus infinity. Bring the minus out. 7 over infinity, you get 0 plus 1. Are we together? So 0 minus 0 is 0. So you get 0 over what? Over 1 raised to power 4. The answer is what? 0 raised to power 4, which is what? 0. 0 over 1 is an answer, which is 0. This one is a valid answer. 0 divided by 1 is 0. Are we together? But it's the denominator that it is forbidden to have 0 at the denominator. You can have 0 at your numerator. So the next one, somebody should try this and try this. Oh, yeah. Try this and drop it in the comment section. Here we have number 8, 9, 10, 11, 12, 13, 14. Try number 14. Drop. So we have 2 questions you want to drop in the comment section now. This is tending to negative infinity. Now number 15. I think I'll just try as much as possible to only stop at number 20 because the video is getting longer and some people, they are very lazy to watch. So I'll stop at number 20. So in the part 3, I will continue the rest, the 15 that is left. And those are very wonderful questions. Very wonderful question. Very wonderful question. So now, let's continue. Now, number 15. This is what? As x tends to infinity, this one now you can use direct substitution. It give you what? Root infinity plus what? Root what? Infinity plus 2. So this one is root infinity is infinity plus root infinity plus 2 is still infinity. Infinity plus infinity is infinity. So you can add infinity together, but you can't subtract it. So direct substitution work for this guy. That's good. Now for this one, limit as x tends to 1 of what? Root x minus 1 over x minus 1. So now what do we have? It's going to give us, now if you put your 1 direct, you get 1 minus 1, 1 minus 1. You get 0 over 0, which is indeterminate. So what are we going to do? We do rationalization. So we can't factorize it. Though we can factorize, but it's an advanced aspect. So, but the best way to attack this is rationalization because what it has root, it is in sod. Are we together? You can do factorization, but we are not going there at all because it's totally going to different from the normal factorization we are doing. So now let's use sod. You know sod. The sod is at the numerator now, so it's going to give us limit. Some of you, they told you that you can only rationalize the denominator. That's a very big error. You can rationalize your numerator too. Limit as x tends to 0 of what? X minus 1 over what? X minus 1 times now root x plus 1 over what? Root x plus 1. We are rationalizing using the numerator because they saw this at the numerator, the root. So we are going to multiply everything again, up and down with everything here, but the sign will change. If we have plus here, this will change to minus. So you are writing this as up and down, but you change the sign. That's how to rationalize. This over this is just 1. 1 times this, I have my question. So this thing, I've not changed the question. I hope you know. But this can cancel this and become 1. Then you get this thing back. So is equal to what? Limit as x tends to what? 0. 1 rather, sorry, as x tends to 1. Root x times root x. Is root x times root x is root x square. Square cancel root, so it is x. Root x times 1 plus root x minus 1 times root x. This thing is just like you are saying root x minus 1, root x plus 1. Root x minus 1 times root x. So that's what we are doing here. This times this times this times this times this. That's what we are doing. So root x times root x, root x times 1, root x, minus 1 times root x, minus root x, minus 1 times 1, minus 1, over x times root x. Now, don't worry, just rewrite that one back. If you have been solving question, then you will know that you don't need to expand that. You will see why. If you expand it, you won't get wrong, but you will still come back to do this thing again. You still come back to join it together. So this time, just rewrite it. So yeah, plus root x cancel minus root x. So the equation becomes limit as x tends to what? 1 of what? X minus 1. You have x minus 1 left there over what? X minus 1 and what? Root what? X plus 1. Now, can we say I don't need to expand this because s minus 1 will go with s minus 1. Cancel out. So it becomes what? Limit. Always be writing the limit for each step until the final stage. Root what? X plus what? 1. So as your x tends to 1, what do you have? It becomes 1 over what? Root 1 plus 1 equals what? Root 1 is 1. 1 plus 1, that's 2. That's your answer. Very easy way to go. So now this one too, you have what? Limit as what? X tends to what? 1, right? Of limit as x tends to 1 of what? 2 minus what? Root 5 minus x over 1 minus x square. If you do direct sub, this 1 square, 1 minus 1, you're getting 0 there. So times, you are using sub now. 2 plus root 5 minus x over what? 2 plus root 5 minus x. Is that clear? So you multiply the numerator and the denominator by the conjugate of the numerator. You are rationalizing by numerator because the surd is there. If the root is here, then you rationalize by the denominator. If the root is on both, you can pick anyone and rationalize by it. The conjugate is that the sign will change. You are writing everything here, but the sign will change. Not the sign inside though, the sign that bind the two terms together. Assuming we don't have 2 minus, assuming we only have this here, this sign will not change. It will still remain because this is just a single term. This is just root 5 minus x. So you multiply, everything will be times root 5 minus x over root 5 minus x. Because it's just a single term. Everything is inside the root. But if you have two terms, then the sign that is binding the two terms together will change when you are rationalizing. So yeah, 2 times 2 is what? 2 times 2 is 4. Is equal to limit as x tends to 1 of 2 times 2, 4. Now, 2 times this, we cancel out this because 2 times this, you get 2 root 5 plus x. 2 root 5 minus x. Minus this times this, you get minus 2 root 5 minus x. So they will cancel out. Just like these two cancel out. This, they will cancel out. So this times this, 4. This times this, we cancel out this times this, so they are gone. So now we have this times this. So it's going to give us 4 minus what? 5 minus x. How do I get that? See, root 5 minus x times root 5 minus x. If they are both root and they have the same thing inside, then the answer is what is inside. Because it's going to give you root 5 minus x square. And this cancel root. Root a times root a is a. Root 20 times root 20 is 20. Root 1 billion times root 1 billion is 1 billion. So root 5 minus x times root 5 minus x is 5 minus x. And because of this minus, and so that's why you have minus outside. So over what? So this one is going to give you what? You are going to have something like, so this one is going to give us, the denominator is going to give us 1 minus s square into what? 2 plus what? Root 5 minus x. So this one, if you open the bracket, get minus 5 plus x. 4 minus 5 minus 1 plus x. So the numerator becomes minus 1. So its limit as x tends to 1 of what? Minus 1 plus x over the denominator becomes 1 minus s square, 1 minus s square multiplied by 2 plus root 5 minus x, 2 plus root 5 minus x. So what are we going to do now? See, this minus times 5 minus 5, 4 minus 5 minus 1, minus times minus s plus x. So what are we going to do next? Oh, sharp. This is what we are going to do next. It's going to give us limit as x tends to 1 of what? Minus 1 plus x over, and don't forget, 1 minus x squared is same thing as what? 1 minus x, 1 plus x. I hope we know. Into what? 2 plus root 5 minus x. 1 times 1, 1. 1 times x, x minus x times 1 minus x, cancel out. Minus x times x minus x squared. So this is same thing as this if you open the bracket. So this minus 1, this plus x. Where do you have minus 1 and plus x? There is none. So what are we going to do? Multiply the numerator and the denominator by minus 1. It's going to give us limit. You know what I'm trying to do? I can use L'Hopital's rule and get it, but try to avoid L'Hopital's rule. Master concept. So this one is going to give you, if you multiply the numerator by minus 1, you are going to get what? Plus 1 here, right? Minus x, right? Minus 1 times minus 1 plus 1. Minus 1 times x minus x over. Now, for you not to change the question, since you have multiplied the numerator by minus 1, do so with the denominator. Also multiply the denominator too by what? By minus 1. So everything becomes what? But you don't need to open the bracket. Just put the minus 1 outside. 1 minus x, 1 plus x, then into what? 2 plus what? Root 5 minus x. So this is 1 minus x. Then 1 minus x cancel 1 minus x. So you have what? Limit as x tends to 1 of what? 1 over this minus. You can bring it out. 1 plus x into what? 2 plus what? Root 5 minus x. Are we together? So now, as your x now tends to 1, at the end of the day, as x tends to 1, you now have minus 1 over, this is minus 1 over 1 plus 1. You know x is now 1. You get 2 there, right? You get 2 there. Open bracket. 1 plus 1, 1 plus 1 is 2. This 5 minus, our x is 1. 5 minus 1, that's 4. Root 4 is 2, right? 2 plus 2, that's 4. No, this is 2. 2 plus this 5 minus 1, since x is tending to 1, 4. Root 4 is 2. 2 plus 2, 4. You already have 2 here, so it's going to give you 2 times 4, 2 times 4. So the final answer is what? Minus what? 1 over what? 8. That's just it, without L'Hopital's rule. Is that clear? So now I think this is number 18 or 19 now. So we are going to have limit as x tends to what? 4 of what? Root x minus what? Minus 2 over what? Root s cubed minus what? Minus 8. So what if you put 4 direct, this will give you root 4 minus 2, that's 2 minus 2. If you put 4 here, 4 cube is 64, root 64 is 8. 8 minus 8 is 0, you get 0 over 0. So we rationalize. This one now, both, if it is cube root, you are not rationalizing like that. There's a way we tackle it. But since both are roots, even though there is cube inside, but both still have roots, so you can rationalize using any of the two. You can rationalize using any of the two, and I think I can still even use cubic factor here, but let me not go to that part. So let's rationalize. We have root x plus 2 over what? Root x plus what? Plus 2. You know I can use cubic factor, this cube, and here I will have 2 cube. There's a way I will do this root, but don't worry. We move on to, we have part 3 commoness. It's going to be more louder than this. So root x times root x, we have what? So it's equal to limit as x tends to 4. Root x times root x is what? X. Root x times 2, that's 2 root x, minus 2 times root x, that's minus 2 root x. So 2 root x cancel minus 2 root x, minus 2 times 2, that's what? That's minus 4. See, if you have the same stuff you are multiplying together, but the difference is just the answer, just multiply the first one and the first one, the last one and the last one, and get out. Because doing the middle, they will cancel out. If I say x minus a times x plus a, just say x times s square, minus a times plus a minus a square. That's the answer. Are we together? Because say s times s square, s times a ax minus a times x minus ax, it will cancel out, so it will remain this times this and this times this. So that's what we have here. Root x times root x minus 2 times 2, that's minus 4. So here, what do you have? You have what? Root, I think I will still use cubic factor, s cubed minus what? 8, right? Multiply by root what? X plus what? Plus 2. This becoming bigger. It's becoming bigger. So I'm sorry, I'm tempted. I don't want to go. I'm tempted. But if they ask you, don't use L'Hopital. See, scratch your brain. The video is becoming bigger. So let me just use L'Hopital through. But there's something you can do. Can still do something. I think so. Yeah. Can do something. I don't want to go to that cubic aspect. It's going to be very, very big. Let me see if I can factorize out something. If I should remove. Okay, let me just use L'Hopital. So it's going to give me limit as x tends to what? To 4. Now differentiate the numerator. Differentiate x, you get 1. Differentiate 4, you get 0. If you differentiate root s cube, well, I don't like this aspect now. If you differentiate root s cube, what are you going to get? Now let's solve that at one side. So root s cube, are we together? We is same thing as x raised to power what? 2 over 3. So it's going to give us 2 over 3 x, 2 over 3 minus 1. So that's what? 2 over 3 x, 3. This 2 minus 3. That's what? 2 over 3 x raised to power what? Raised power minus 1 over 3. Is that clear? So it's same as, so it's same as 2 over 3 cube root x. Are we together? Yeah. Root s cube. 2 over 3 cube root x rather. See, x raised by 1 over 3 is cube root x. S raised to power 1 over 2 is root x. And since this is minus inverse, down. So if you differentiate this one, we get 2 over 3 cube root x, right? Then minus 8. Are we together? If you differentiate root x, that's 1 over 2 root x. Now you can try and differentiate that. Root x, if you differentiate 1 over 2. Oh, this is even, sorry. What am I even doing? This is multiplication. So this is going to give us something like, it's going to give us something like, what's it called? Product rule. It's different. The numerator, you get 1. The denominator now is 2 terms. So you are going to use product rule. So you don't just differentiate 1 by 1. And all those ones we are doing 1 by 1 is because it is plus minus that separate them. If you have x squared minus 2x, then it's changed to 2x plus 2. But this one is this times this. So we have 2 terms. You are not differentiating them separately. The denominator now is product rule. So you are going to use product rule for the denominator. So that's what we are going to do. So now let's deal with product rule for the denominator. So now for this particular question that can stress you, now they can ask you to use L'Hopital rule because they know that it will stress you. The numerator is already 1, right? So that's what? Limit as x tends to 4 of what? 1 over. Now let's differentiate the denominator. So this is root x cubed minus 8 root x plus 2. So this is your u, this is your v. No product rule now. V du over dx plus what? U dv over what? Over dx. So what's our v? Our v is what? Root s plus 2, right? Now what's du dx? If you differentiate this u, du dx, I've done the other time. That's 1. If you differentiate this, 1 over 3 cube root x. If you differentiate it, you get minus 0. So this v du dx plus u. What's our u? Root s cube minus 8 u dv dx. This v dv dx, if you differentiate v, that's what? 1 over what? 2 root x plus, if you differentiate 2, that's 0. So this, how to differentiate the denominator, because its product is 2 times, so you are using product rule. You are not just differentiating this. Do you get? It is only if it is just like, if we have this minus this plus this plus this, then you can differentiate one by one. But since it's product, so you are using product rule. So at the end of the day, that question becomes limit as x tends to what? To 4 of what? 1. The numerator was x minus 4. If you differentiate x minus 4, you get 1. Now if you differentiate the denominator, so you get what? Root x plus 2 over what? 1 over what? 3 cube root x, right? Plus what? Now, yeah, plus, thank God, I thought we have problem again. Thank God. S cube minus 8 into what? 1 over 2 root x. When I realized that this will give me 0, I thought there's a problem, but thank God it's addition in between. So as my x tends to 4, I'm going to have what? 1 over what? Now this is become what? Root x plus 2, that's what? Sorry, this what was it called now? This is just root x. The plus 2 is outside, it's just root x, then plus 2 outside. The 2 is not under. Sorry, the 2 is not under the root. So what's root x? If x is 4, that's root 4. So here I'm having root 4 plus 2 into what? 1 over 3 cube root 4 plus what? Root what? 4 cube minus, the 8 is outside, sorry, 4 cube minus 8 into what? 1 over what? 2 root what? 2 root 4. So it gives me 1 over, root 4 is 2 plus 2, that's 4, 4 into 1 over 3 cube root 4 plus, this is root 64. Root 64 is 8. 8 minus 8 is 0. Everything here will give me 0. So my answer is 1 over 4 into 1 over 4 into 1 over cube root 4. But I can still expatiate further. Is equal to, if you have 1 over 4 into 1 over what? 3 cube root 4. Are we together? So it's going to give me what? 1 over 4 times 1, then 4 over 3 cube root 4. So it's going to give me what? 1 divided by 4 over 3 cube root 4. Then I'm going to get 1 multiplied by 3 cube root 4 over 4. So the answer is going to give me 3 cube root 4 over 4. That's the answer. 3 cube root 4 over 4 using L'Hopital's rule. I hope we get this. You can back the video and watch. So the next question is limit as x tends to 0 sin x over x squared. Now this one, now if you put 0 direct substitution, sin 0 is 0, 0 squared is 0, indeterminate. Now let's use L'Hopital's rule. Are we together? Using L'Hopital's rule. All these signs, some of the times it is L'Hopital's rule you just decide to use. Are we together? Because most of the time, any kind of method you want to put, you still get your indeterminate. So L'Hopital's rule is better. So now if we use L'Hopital's rule, it's going to give us limit as x tends to 0. If you differentiate sin x, what do you have? Cos x. If you differentiate x squared, what do you have? 2x. Cos 0 is 1, but 2 times 0 is still 0. Can you see? But note, in L'Hopital's rule, limit as x tends to 0 of f of x over g of x is equal to limit as x tends to 0 of f prime of x over g prime of x is still same thing as limit as x tends to 0 of f prime prime of x over g prime prime of x. You can differentiate the numerator second time, the denominator second time, if the first derivative of the numerator and denominator gives still giving determinate or undefined. You can continue till you get a determined answer. So now you can see, if I differentiate first, numerator cos x, denominator 2x. Cos 0 is 1. This one 2 times 0, that's 0. 1 over 0 is undefined. So you can still continue. Is equal to limit as x tends to 0 of differentiate cos x. What do you get? You get minus sin x, abi? Yeah, minus sin x. Differentiate 2x, that's what? That's 2. So now if you put your 0 now, as your x tends to 0, so you get minus sine 0 over what? 2. What's minus sine 0? That's 0 over 2. So which is what? 0 over 2 is what? Is equal to what? Is 0. So that's an answer. Since you don't have 0 at the denominator. If you still have 0 at the denominator, differentiate the third time. If you still giving the denominator undefined, differentiate the fourth time. Are we together? You can do, there's a particular question in our Math 102 workbook. We differentiated 6 times before we get a valid answer. So, L'Hopital's rule, you can continue your differentiation till you get a valid answer. So for this one, limit as x tends to infinity of e raised to power x over x. Direct substitution, what do we have? We have, is going to give us e raised to power infinity over what? Infinity. This is what? Infinity over infinity, because e raised to power infinity begins to grow exponentially. Normally, the answer is infinity because this one grow faster. Then this one is just normal infinity, but you can't determine it. So you can't. How do you know that your answer is infinity? Because this one is half exponent of infinity. It grows faster like anything more than this. So it will give infinity, but this is not the proper way to get to infinity. Now let's solve it to get our infinity. Equals to limit as x tends to infinity. Then how are we going to solve that? And if you use that method of dividing everything by the x that have the highest power, the denominator, you divide this over x, x cancel as 1, you still get this question back. So forget that method. And we are dealing with highest power of x, not x as power. Like that aspect that you divide everything by the highest power of x. So this one now, the denominator, the highest power of x is 1. Even though e raised power x is at the denominator, you can't divide everything by e raised power x because it is e that is raised to power of x. X is the power. That x asks to have a power of number before you can do that. Sure you get. So now, what are we going to do here now? I don't want to use L'Hopital's rule. So let's use L'Hopital's rule. Differentiate the numerator and the denominator separately. Now, e raised power x, if you differentiate e raised power x, you still get e raised power x. Are we together? If you differentiate x, you get 1. Don't forget, if you want to differentiate exponential stuff, exponential raised to power, you differentiate the top. If you what's the top? What's the power? You differentiate the power. What's the power? 1. Then you multiply it by the whole question, e raised power x. That's your answer. The derivation of e raised power anything is the derivative of that thing multiplied by the whole question. So this guy give us e raised power x over 1. Now put your infinity. Then you get e raised power infinity over what? 1. Which is what? Infinity. So the next question. You have this now. This is a very standard question. It looks familiar with what we did in exam then, but that one is more bigger than this, like 4 different values. This times this over something times something. So if you put your 0 direct, if you put x as 0, anything, 5 raised power 0 is 1 minus 1. 10 raised power 0 is 1 minus 1. Anything raised to power 0 is 1 except 0 and infinity. 0 raised power 0 indeterminate, infinity raised power 0 is indeterminate. But every other thing raised power 0 is 1. So if you raise 5 to the power 0, you get 1 minus 1 is 0. 10 to the power 0, 1 minus 1 is 0 over 0 indeterminate. So what are we going to do? You can use L'Hopital's rule. You are going to have, okay, let me see if there's a way. I don't want to use L'Hopital's rule here. If you use L'Hopital's rule, you can get your answer. That's when lane will be coming in. But I don't want to use L'Hopital's rule. If you want to use it, you can differentiate the numerator separately, the denominator separately, then input your limit to get your value. But let's see what you can do without that. So I might also use L'Hopital's rule. You still get, so as x tends to 0, standard limit of a raised to power x equals to 1 plus what? X ln a. You know the standard. As x tends to 0, the standard limit of a raised to power x is 1 plus x ln a. You know, using standard limit is also another. So it's going to give us limit as x tends to 0 of what? 5 raised to power x. That's 1 plus 5. 1 plus x rather. 1 plus x ln 5. Then we have minus 1. No, a raised power x is 1 plus x ln a as x tends to 0. It's a standard limit. So 10 raised power x, so it's going to give us 1 plus what? 1 plus x ln 10. Then you have minus 1. Minus 1. So 1 minus 1 cancel out. So it becomes what? It becomes, what is it called? X ln 5 over what? X ln 10. Are we together? So you don't need to put this 0 again. If you put it, you get 0 over 0. But x can cancel out. You already made use of it as x tends to 0. Then the standard limit of this is this. Not that you can't put it again at the end of the day, but if you have more values that will not make this indeterminate, you can put it. But so far that this already cancel out, right? So we have cancel it before you put it, because it can cancel out and is valid. We have ln 5 over what? Ln 10. So there's nothing to substitute again. This is the answer. But if you want to use L'Hopital's rule, let me look for space. If you want to use L'Hopital's rule, using L'Hopital's rule, 5 raised power x minus 1 over 10 raised power x minus 1. You differentiate the numerator separately. 5 raised to power x is going to give you this problem. 5 raised to power x, you are going to get okay, let's solve it. If y equals to 5 raised to power x, then let u be what? Let u be x. Du over dx equals to what? 1. Are we together? What am I even doing? Am I forgetting how to solve something like this? Looks funny. Oh, sorry. Rubbish. Take ln of both sides. You have what? Ln y equals to what? Ln what? 5 raised power x. If your x, you used to differentiate with respect to x in some cases. So if that respect is the power now, you make sure you bring it down. So how do you bring it down? By taking ln or log of both sides. So ln y equals to ln 5 raised power x. So ln y equals to what? 5 x rather. That x will come down. X ln what? Ln 5. So now I'm coming. What's the next thing here? Ln y equals to x ln 5. So am I forgetting this thing? Now okay, the derivative of ln x equals to 1 over x. You want to differentiate ln x, you get 1 over x. Now if you differentiate both sides, this one turn to what? 1 over y dy over dx. Now if you have 2x, if you differentiate 2x, you get 2 with respect to x. If you differentiate 2y with respect to x, you get 2 dy over dx. Once it is not x, you add dy dx. If it is x, you get 2. But if it's another alphabet and you are differentiating with respect to x, you get 2 again, but you add dy dx. 2f with respect to x. You want to differentiate f squared with respect to x, it gives you 2f dy over dx. But if it is x squared, you just get 2x. Do you get? So you want to differentiate ln x is 1 over x if you differentiate. If you want to differentiate ln y, you get 1 over y dy dx. Is that clear? Equals to, if you differentiate this guy, product rule. If you differentiate s ln 5, this v, this u, this v, v du dx, you have ln 5. These are v, du dx is 1. So plus ln 5 times 1 ln 5 plus u dv dx. This is our u. Our u is x. dvds ln 5. If you differentiate ln 5, what do you get? You get 0. It's a constant. If you differentiate a constant, you get 0. These two terms, you are multiplying two terms together. We've differentiated this side and you want to differentiate the right side. So this uv, the product through v du dx plus u dv ds. Our v is ln 5. Du dx, this u, du ds will give you 1 if you differentiate x. Ln 5 times 1, ln 5. Plus u dv ds, this is our u. Dv ds, if you differentiate v, you get 0. So 1 over y dy over dx equals to what? Ln 5. So dy over dx will give us what? Ln 5 multiplied by what? Multiplied by y. Is that clear? Because if this 1 over y is coming to this side, it becomes multiplied by y. So dy dx is equal to ln 5 multiplied by, what's our y? Our y is 5 raised to the power x, right? 5 raised to the power what? X. Yes, I think I'm right. I'm coming. So that's the answer. Dy dx of 5 raised to the power x is ln 5 raised to the power x. So at the end of the day, what is the question? If you want to do this, so it's going to give us limit as x tends to 0. 5 raised to the power x is what? Ln 5 multiplied by 5 raised to the power x. Then here, if you differentiate minus 1, you get 0. Over, now the denominator will give you what? Ln 10 raised to the power x minus 0. You differentiate this, you get ln 10 raised to the power x, because this one give you this. If you differentiate 1, you get minus 0. So at the end of the day, you get what? You get limit. I'm using that space. At the end of the day, you get limit as x tends to what? Is 0 of what? Ln 5 multiplied by 5 raised to the power x over what? Ln 10 multiplied by what? 10 raised to the power x. Is that clear? So now put your 0 as n tends to 0, you get what? Ln 5 into what? 5 raised to the power 0 over what? Ln 10 into what? 10 raised to the power 0. So what? 5 raised to the power 0 is 1. 10 raised to the power 0 is 1. So you get what? Ln 5 over ln 10. Ln 5 over ln 10. That's the answer. Please go and learn to differentiate something with power of x. I've explained enough. Back it and learn it. So for this question too, as x tends to 0, we also have standard limit for this one. The video is getting much longer. How many do you have left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 questions left. I'm coming back to this. Now, let me quickly solve this. As x tends to negative infinity, what will be this? You can use direct substitution. It's going to give you what? Negative infinity square multiplied by what? E raised to power what? Infinity. Negative infinity square is infinity. E raised to power infinity is infinity. Infinity times infinity is infinity. It's determinate. Infinity times infinity is an answer, infinity. So that's that for that. Which one again is more direct here? So you have this x cubed minus 8 over what? X minus 2. So what are you going to get? So this one now, this cubic factor is same thing as limit as x tends to what? 2 of what? S cubed minus what? 2 cubed over what? X minus 2. So it's going to give us limit as x tends to 2 of what? This x minus 2 into what? S squared plus 2x plus 2 square, which is plus 4. The cubic factor, I wrote the formula the other time, s minus 2. I gave a formula that a cube minus b cube equals to what? A minus b into what? A square plus ab plus what? B square. Are we together? So a square plus ab plus b square. So this guy cancel this guy. This factorization, because if you use direct sub, you get 0. 2 cube is 8. 8 minus 8 is 0. 2 minus 2 is 0. So yeah, at the end of the day, it's going to give you limit as x tends to 2 of what? S squared plus 2x plus 4, which is same as what? 2 squared plus what? 2 into 2 plus 4. And that's 4 plus 4 plus 4 equals to what? 12. Is that clear? So that's that for that. Okay. Let's just try as much as possible to get. Now, if you use direct sub, e raised power 0 is 1. E raised power minus 0, that's 1 is still 1. You get 1 over e raised power x, 1 over e raised power 0. E raised power 0 is 1. So if you put 0, you get 1. This one, if you put 0, before you put 0, this one will change to 1 over e raised power x. So it's still 1 over 1, 1. But this one will be 0. You get 2 over 0 undefined. So let's use L'Hopital's rule. Let's differentiate the numerator and the denominator. So it's going to give you limit as x tends to 0 of, if you differentiate e raised power x, you get what? E raised power x. I told you, differentiate the power, then multiply it by the question. If you differentiate s, you get 1 times this. So plus, if you differentiate this, you get minus 1, right? Times this. So this one becomes minus e raised power minus x over what? If you differentiate x, you get 1. So at the end of the day, this guy will change to limit as x tends to 0 of what? E raised power x minus e raised power minus x over 1. We have used L'Hopital's rule by differentiating the top and the down. Are we together? If you differentiate this guy, if you have exponential raised power something, differentiate that top, then the answer, multiply it by the question itself. So if you differentiate the top, differentiate s is 1. 1 times this is this. That's the differentiation of e raised power x. If you differentiate this top, you get minus 1. If you differentiate minus x, you get minus 1. Minus 1 times this, you get this. If you differentiate this x, you get 1. So that's it. Now put your 0. So it's going to give what? E raised to power. So as x tends to 0, you are going to get e raised power 0 minus e raised power, let me write it. Is limit as x tends to 0 of what? E raised power x minus 1 over e raised power x over 1. You know this negative x, so you can take it down. So to become, so as your x tends to 0, you get e raised power, as x tends to 0, you get e raised power 0 minus what? 1 over e raised power 0 over what? Over 1. E raised to power 0 is 1 minus e raised power 0 is also 1. 1 over 1 is also 1 divided by 1. So you get what? 0 over 1, which is what? 0. The answer is 0 for that one. We solve this. Now the next question. So I think that's about, out of 35 questions, that is about 26 that we've solved. And I hope you've learned. We are in the morning now. I have work to do. I'm going to work, and the video is getting longer, very much longer. Are we together? So in the next video, snap this. You can try it. Snap this. 1, 2, 3. Those are simple questions, but you have to. It's kind of technical, but it's not hard. 4, 5. This one is still direct. You rationalize. You don't have issue with this. There's no issue with this. You rationalize. There's no issue with this. You rationalize. 6, 7, and the last one. There's no issue with this too. So these are the 8 questions left. So in the part 3 of the limit, this 10 days journey of limit, I'm going to start with this 8. So I think we've solved 26. Yeah. So thanks for the video. Drop a like and drop a comment. We'll continue from where we stop in the next class. So we are going to try as much as possible. In the next one, at least we are still going to solve 25 questions. Plus this 8, because if we add this 8, it's going to take long. So let's just say 25 minus 8. So we are going to solve, let me say we are going to solve 20 brand new questions, except this 8 in the next class. 20 brand new questions that will also sharpens your knowledge. So thanks for watching. Drop a like, drop a comment, then subscribe.